Hello, everybody. Hi. Today, we're going to have a lot of math fun. We're going to be exploring patterns with ones and with zeros. We are going to explore multiplication with ones and zeros. And we are going to analyze. To analyze is to look or to study very carefully. So, let's get started. This lesson will be very easy today, and it will get you to learn something new. Explore patterns with ones. What patterns do you see below? Okay, this is kind of like a table in a sense. But what patterns do you see as we go along? Spot as many patterns as you can. Frenchie? What patterns can you see? This is interesting. There are a lot of ones here. That's right. Filled and flooded with ones. There's also ones here. Couple of ones there. Tens to twos, twos to tens here. There's a multiplication sign. We're multiplying. That's right. If there's a multiplication sign, that means we're multiplying. Great job. Even the most obvious little signs can make a difference in learning. Because although you already know that this is multiplication, it can actually make you smarter. So, if you see a multiplication sign, it obviously means we're going to multiply. So, but it's multiplication by ones. So, if we look over here, let's do 1 times 1. 1 equals 1 times itself, which equals 1. 1 is 1. That's it. One lot of 1, or one group of 1, is just 1 all by itself. It's kind of a lonely number. Do you guys remember that metaphor? 1 is the loneliest number? Well, that is not true. There are obviously numbers that are smaller than 1. But 1 is the smallest positive number. 0 isn't, because 0 is a neutral number. It's between the positive and negative numbers in a number line. And 0 represents nothing. So it's no way it can be positive or negative. So we account 1 as the smallest positive number. You will learn more about positive and negative numbers when you get to 6th grade. But we are not going to worry about that. Right now, we're just going to worry about ones and zeros for today. Okay? Keeping this on track? All right. What else do we notice here? Let's increase the difficulty level. How about 5 times 1? 5 equals 5 times 1. What do you see over here? Why are all these pluses there? Why are all these ones over here arranged? Frenchie? 1 plus 1 plus 1 plus 1 plus 1. Oh, I see. Every time we increase this number by 1 more, we add another 1. All the way down to the bottom. That's right. It's kind of like a math pyramid, where this is the tippy top, and where this is the very low bottom flat surface. Do you know those famous triangle buildings in Egypt? Those are pyramids. Same thing with math. Although this is actually not a pyramid, it's actually a triangle. But you'll learn more about 2D and 3D shapes when you advance up, or when you age up to 4th grade and beyond. But besides that, although it's a triangle, it can work very temporarily as a pyramid. Because this can 3-dimensionally represent the tippy top of the pyramid, and the bottom of the pyramid. The bottom is the greatest width, which makes sense because we're adding the greatest amount of ones. The tippy top is the least width, the least amount of numbers we're adding. So, analogies like this can really help you understand math better. But what about these blocks? Let's see these blocks. What do you notice about these blocks? Okay, there's 1 block, there's 2 blocks, there is 3 blocks. 1 block plus 1 block plus 1 block makes all 3 blocks all together. There is a group of 3 blocks, which means that 1 times 3 blocks equals 3 blocks altogether. Wait a second. Circling the blocks is the same thing as adding these ones. 3 times 1 is 3, which equals 1 plus 1 plus 1. That's right, and if we do it the long way, which is not pretty long, 1 plus 1 is 2, and 2 plus 1 is 3. So that's how we can double check to see if 3 times 1 is really 3. Think about multiplication as repeated addition, guys. Now, we know that addition is one of the 4 basic arithmetic operations, the other 3 being division, multiplication, and subtraction. Addition is when we add or combine some numbers together to make another number. But why do we need all these plus signs when you can make a multiplication sign or multiplying? That is an obvious analogy. If we see a multiplication sign, we're multiplying. If we add all these numbers together, we don't need all these plus signs. We could instead make one multiplication sign to make this problem go a lot faster. For example, in 10 times 1, instead of doing 1 plus 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 1, this is very boring. We could just remove all these plus signs and make it into one multiplication sign. 10 times 1. Phew, that is a lot faster, which equals 10. So multiplication is repeated addition. Although repeated addition may seem like a boring concept, it is actually multiplication behind the scenes. And it's actually pretty cool. That is how the base of this mathematical pyramid is even formed, with the tippy top being only one number added. We're not even adding a number. 1 plus 0. Just 1. But now, let's get into the zeros. 0 is a number that means nothing, which I just told you. What patterns do you see below? Wait a second. There are no blocks shaded. There are 0 blocks shaded. That's right. If you do not see anything in the set, kids, that means there are 0 objects. You should know that in preschool and kindergarten. But you could also learn it in 1st grade when you have the chance. But in 2nd grade, I don't think you can learn that. I think you'll graduate what learning the number 0 is when you reach from 1st grade. So now, 1 times 0 is 0. Very obvious there. That is one group of 0. Same thing for these blocks. We are not circling any blocks. 1 lot of 0 is 0. 2 lots of 0 is 0. 3 lots of 0 is 0. 2 times 0 is 0, which equals 0 plus 0. 3 times 0 is 0 plus 0 plus 0. So this is also kind of like a mathematical pyramid, where the tippy top is 0, but ironically, the bottom is also 0. Why? Let me explain. 10 times 0. If we multiply anything by 0, the answer will always be 0. So that is why the tippy top and the bottom of the pyramid are both 0, and all of these are also both 0. Because if we do this the long way, here we go. 0 plus 0 is 0. Plus 0 is 0. Plus 0 plus 0. Plus 0 is 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 0. Plus 0 equals 0. Finally, but the long way can actually be a very good part in math. Because although math has some helpful shortcuts, shortcuts are not always helpful in math. There are when and when not times to use shortcuts. In fact, some shortcuts can be so wrong that they can create a whole mathematical error, which can make the problem unsolvable or make it wrong. So, that is how we can get these math concepts tied together. But of course, just like any other number, we can go on forever, and they can go on forever too. So we can't just stop at 10. Why stop at 10 when we can keep going? 11 lots of 0 is 0. 23 lots of 0 equals 0. 64 groups of 0 is 0. 97 groups of 0 is 0. Same thing with the ones. 37 groups of 1 is 37. 97 groups of 1 is 97. 86 groups of 1 is 86. So, that's a great way to analyze this. You don't have to circle all the individual blocks, but this is a pretty good thing. You could just circle these overall sets so that you can circle multiple blocks at a time. Same thing over here and over there. So this can be very great for understanding patterns. All right, that's it for me today. I hope you had fun. I hope you learned a lot about multiplication with ones and zeros. And I will see you guys later. Bye-bye. Bye.